here we have another example where we have to solve the problem where we have to find center of mass using the integrals. Okay, the problem was taken from the book. Find the center of mass of thin wire of mass m, and the length L, bent in a semicircle shape. The let origin be at the center of the semicircle and have the y arc from the positive x, so start from positive x, crosses the positive y, and terminates at the negative x. Okay, so we have to find the center of mass of the semicircle. M is given, L is given. So how can we find it? So first of all, basically we have to take the very small piece of it. Okay, this very small piece of it, it has a mass, so it's very small, so I call it dm. Then this length of this small length will be dl. Okay, since we know that take the length will be like total length will be l, and then that will be the dl. Okay, then after that, this dl is very small. In my case, let's make it kind of zoom. Okay, actually take it very small, but let's zoom it, and then the angle of this one is very small. Okay, so therefore this angle will be d theta. Okay, then we have the radius of the semicircle, so let's call it r, and then this very small d theta is at any theta. Okay, here. What else? Then this d theta, we have the theta, we have at any theta. Then we have we have this length. Okay, that length is y. Okay, at any y. So that one at any y is basically equal. So the this y, any y, is equal to the r times sine theta. Okay, then we have this length, which is x. Okay, this x at any x is equal to the r times cosine theta. Okay. Now, since this semicircle is very thin, then we can say that its lambda linear density is equal to the total mass divided by the total length. Now, since it's a semicircle, we know that the length of the semicircle is pi r. Okay, and this is also equal to the dm divided by the dl. It's very small mass divided by very small length. Now, this dl is basically equal to the r times d theta. Then we can substitute this formula where dm over dl will be equal to the dm divided by the r d theta. Then what else? Do we have lambda? Seems we don't have a lambda, correct? Then we can say that since we know that the capital mass is given, total mass, and then pi r, from here, as we solved in the previous problem, we have to find dm. Dm will be equal to the mass times r times d theta divided by the pi r. So the r will cancel with r. We have m d theta divided by the pi. Okay. Then we know that the general formula for finding the center of mass, where x center of mass is equal to the integral of x dm divided by the dm integral. Okay, since it's x and y coordinate, we have to find center of mass for the x and the center of mass for the y. Okay, is equal. Now let's find center of mass for the x. Integral of the x dm is equal to the mass d theta over pi. And then now since we know the total mass is already given, then we know that if you integrate from 0 to the capital M, you will basically get straight away the capital mass. Okay, so you don't need to integrate bottom side because its total mass is given already. Okay, what else? So now we have the idea is basically here we try to integrate the theta. Okay, therefore we have to somehow get rid of the x. Okay, let's continue. So the integral, now in our case x is equal to the r cosine theta. The masses, since it's constant, we can just also cancel masses. R cosine theta d theta divided by the pi. Okay. Then since we're trying to integrate the theta, our limits will start from 0. And ends in a pi. So the limits will be from 0 to the pi. That's it. So we found now the rest of the thing you can solve it yourself for the center of mass for the x. Now what will be the center of mass will be for the y. So the y center of mass is equal integral y dm divided integral of the dm. Okay, we don't need to integrate bottom side because it's already m, so we can say that the y dm integral divided by the capital mass, which total mass basically, is equal. Now the y is in this case is equal to the r sine theta. Dm is equal to the capital M d theta over pi, and then we have this capital M, so M cancels with M. Then we have integral r sine theta d theta divided by the pi. Now what are the limits for the y? Also it starts from 0 to the pi. Okay, so that's it. You have to integrate it. After that you have to put the limits and you can get center of mass for the x and also for the y.